debug, that kind of stuff, security on the platform. I also make really unnecessary things. So this is a arcade cabinet that I turned into Rocket League. There was some reverse engineering involved to get that to work. I made an arcade cabinet that serves beer. I know y'all love that. So there's a keg underneath that. So that runs up to the line. Most of that's 3D printed and CNC. And then this abomination. So we made a deploy button where if you hit the button, it would deploy production, which was really nice. It was kind of fun. You'd get salespeople to come and mash it. And then we had somebody go remote. So I made it IoT. So I stuck a chip in it. And then whenever you did that, it would start recording, spin a servo, hit the button. There's nothing else I can tell you. That's what that is. All right, so what is IoT? The IoT is a system of unrelated blah, blah, blah. It's crap. So this, I wish I was making it up, this is an IoT candle. So you can turn it off and on remotely.
Okay.
This is a toothbrushing app. So your toothbrush is connected to the internet, so it knows if you're brushing your teeth right, because time is not the biggest factor. Sometimes it's actually pretty useful. You want to feed your cat remotely, there's a good way to do that. You can make sure they have water, you make sure they're not tearing up your furniture with a camera, that kind of stuff. So that's actually pretty cool. Sometimes it's actually crap. That is an internet connected toilet. So none of these are made up. And the ongoing thing is that the S in IoT stands for security. So I'm glad some of y'all haven't heard that. It's a really reused joke. So this is what people think I do. Being in security, people think that I probably shouldn't be touching a computer, stuff like that. I actually don't, because I hate fixing computers, so I don't want to touch it. And I spend as much time offline as I can. What I actually do is a little bit of this. I don't actually know. So my path here has been kind of interesting. It's been very dev, very DevOps, SRE, that kind of stuff. Security is really just the same old, same old. So what I really do is, when something's not working, I figure it out and make sure it's secure. It's a lot of architecture. So I'm actually going to teach y'all how to brew beer today. So I don't know if you know this, but brewing beer, there's a secret. It's actually really easy. There was a rule, I think, in a law in Germany in 1516, the German purity rule. And what it is it said that it's not called beer unless it only has water, hops, and grain. And they actually forgot there's a fourth ingredient, which is yeast. But that's all it is. It's just grass, which is barley, toasted or not. That's what gives you flavors. That's what they call like malts. You can have adjunct malts. I'm going to distill it down. A lot of people are going to hate me. There's a lot of beers. But it's grass, it's hops, which is just a plant that they discovered, treats beer really well when they were sending it to India. That's why you have IPAs. It had to go a really long way. They wanted to make sure it stayed preserved, so they threw this plant in it. And there's water and yeast. And yeast is actually what it's kind of like the other form of meat. It eats sugar and produces alcohol. So when you make beer, really all you do is you take all those ingredients, put it in what's called a mash tun. And what you're really doing is you're steeping tea of all these ingredients. What you're trying to do is get these ingredients to release sugar. That's all you're trying to do. There's a lot of science involved if you actually want to make good beer, right? You have temperature, you have steep time, all these other things, pH of the water. There's a lot of other factors that come in. But really what you're doing is you're just steeping it. You boil it, just throw it all in there. That's really just to kind of clean it up, make sure there's no bacteria for the most part, because it'll kill anything. You ferment it, which is the most important part. Without fermentation, you wouldn't have alcohol. You just have this really weird bread of water. And then this is the fermentation is really what I want to get at today, because I actually have a device that I want to go over of how that plays into this. So when you're done with all that, you cool it, you throw yeast in it, it eats the sugars that you produced, produces alcohol, and then you carbonate it. That's the last thing. So when you're brewing beer, the most important thing is called gravity. And so gravity is really just this measurement of what's in there that isn't water. So if it's, water is 1.0 gravity. So that just means there's nothing else in it, it's 1.1. So if you have something you measure it and it's 1.09, what that means is actually 9% something else that you're assuming is sugar, more than water. And that's important because what you want to do, you want to see how your yeast is doing, you want to see how you're producing alcohol. So if you start with 109 and you end at 109, you didn't do anything, right? You pitched bad yeast, there was no sugar, there was something that went on. And really, that's also the only way to calculate alcohol. So you take what's called the original gravity, which is at the beginning of your fermentation, you measure how much is in there. And then you kind of pitch the yeast, you let it do its thing for a couple days, it starts to die off, and then you take what's called final gravity. And then there's a formula that you use to turn that into ABV, so your alcohol. So the two ways to do this, there's one that's very invasive. So what you have is this floating kind of thing that, the density is how much it'll float up or down. It's very invasive, right? Because what you don't want to do is you don't want to mess up your beer. You don't want to introduce bacteria. So you have this thing that you literally just dump in there, read it, and then you're done. There are other ways to do it that are non-invasive. That's a refractometer. And what you do is you can just take a drop, which is really nice because you don't have to worry about it. You can actually take the water out, put it on there, and see what it is, and it'll give you a reading. So that's way less invasive, and it's really nice to take. And then there's this. I actually brought one of these. So this is a tilt hydrometer. So it's the same thing as this, really. You just drop it in there. The difference is I don't have to read it constantly. It's actually emitting the data to me, which is really nice. So I don't have to sit there and open up the beer, which is what you don't really want to do as much as possible, and keep reading it to see how you're doing. You just drop this in there, and it's continuously updating something with the gravity that it has. So you get this nice graph of how much gravity is left. Now, they have this app. It's really painful to see. So what it does is actually Node-RED, which is this weird dashboarding language. So I'll actually show part of the reason that I don't like it. So it looks kind of simple. There's really no automation involved, right? There's these instructions, and they're kind of gross. I don't like that. I'm lazy. And then there's this configuration file. And I am hard-pressed to call you good for giving me this config file. So as soon as I said that, I said, I'm not doing that. So, like every good engineer, I can do that, right? Probably not gonna, but I can do that. So, what it actually is, this emits a Bluetooth iBeacon packet. And what that is it's something that was invented by Apple. And what it does is it's a Bluetooth event that's a very low battery. It's basically just a pulse. And the packet that it emits has different data on it. Maybe you have a tile that's like telling you location, proximity, all these other things. Most of those do something in their iBeacon packet. And you can tell it's Apple because it starts with an I. So in this packet, if I know that this thing is emitting it, and I know I can receive this Bluetooth event, I know that I can do something better myself. So I'm going to go through the process of reverse engineering this. The good news is I don't have to start from scratch. A lot of people have done this, especially with iBeacon, and other people that have done this in other ways with the tilt hydrometer itself. And so what they do is they took this packet that it sends in hex, and they kind of broke it up by the meaningful information there. So I don't really have to start from scratch. I just have to, put this logic into something else. So going from that part's not too important. The important part is that, smarter people have started this. So we're going to steal a packet. And what that means is I'm actually going to go through and I'm going to read some Bluetooth data, but I'm looking for this specific one, right? Because I want to write my tests, and I want to write this library that parses the specific set of data, because I know all of these are going to be emitting the same data. So how can I find that? Well, what I do know is the MAC address. So they're required to give you the MAC address because it's FCC, right? So I know the MAC address, and I also know that the MAC address is somewhere in that packet. So I'm going to be lazy, and I'm going to do a very, very brute force lookup, and I'll go through that. Make that look readable. So some of this is just wrapper code, right, for starting and stopping a socket using Blues, which is the Linux Bluetooth stack. So the most important thing is basically I'm just going to open up a Bluetooth device, and I know bits and pieces of this MAC address. So I'm just going to do a brute force look, and I'm going to parse every bit of data that's in each packet. And when I find 3 of them, I'm going to mostly assume that that's the one I'm looking for, because I don't really know what order. I don't know if it's big endian, little endian, all these other things that come into play. I just know it's going to be somewhere in that packet. When I find 3 of them, I want to jump in, because maybe that's the one. So maybe I'll just do print packet. And I'm not going to make you suffer through all the work that I did there, because I had to do it a bunch of times before I found it. So I finally found this one, and I knew it was mine because the MAC address existed, and I know the MAC address I'm looking for is 907701, and it turns out it's this one. And the MAC address in this is backwards, so we're going to have to reverse it. But I know this is the packet I'm looking for. So at the bottom, you can tell I just did print, and what I get is the byte stream. So this is the whole packet, all of it that is sent. So I'm going to use that as the basis for my Python library. So now that we have that, I can actually use TDD. I can start a test and make sure that I'm getting the data that I want to do. So just a simple PyTest. Here's the hard-coded packet that I know I had, and I want to assert that this function that I'm going to fix up just returns the MAC address. That way I know I'm on the right track. So the code now changed from that gross, brute force that I had. I have the find MAC that basically just takes it, calls a new function, I give it the part that I knew, and I know that's the area that I'm looking for because I stole it here, right? So I know it's from 3 to 9 contains a MAC address, and I just need to make sure that it comes back the way that I want it. So parse it, return it, run a test on it, and it passes, so I know that that's the right way to find the MAC address. So I know I'm on the right track. So now that I have the MAC address, that's not everything, right? I need the gravity. I know that this thing submits the gravity. I know it submits the temperature, MAC address, and UUID. The UUID for these is interesting because they have 10 models. So the way you do it is that if you have 10 beers brewing and you want 10 of these in there, they go by color. So you wouldn't buy 2 of the same color, right? You'd have a black one, a yellow one, a green one, and you know that the black one is that beer, the green one is this other beer. So that's your way of mapping those. So I have this known set of UUIDs that I need to parse. So those are the 3 things that I need. I need the UUID, the major, and the minor. Now it's cool because they've told me that. The library that they released has this list of UUIDs that is known. So I now know that exists somewhere in the package. So I just got to make sure I pull out the right slide. So these are the different models that they have. This is the UUID that will always exist for that model. So depending on the packet, that's the one that you're looking for. So there's that list. Now, what I'm going to do, I no longer have to brute force, right? I know the MAC address, but I don't want to find out the MAC address. I just want to say if any of these contain this known set of UUIDs, I know it's a till hydrometer, and that's the one that I want. So we're going to rewrite it that way. So there's my test. What I want to do now, I do kind of want the MAC address maybe for later, but now instead of just returning the MAC, I'm going to return the dictionary with the MAC and the UUID. And this is my model. This is the black. If you look it up, it has the black color on it. So no, that's the one I'm looking for. Let's go back to the code. And what I have is now this constant, right? This dictionary of these known ones. And I have a test one. I can get into that later. Basically, I have a iBeacon submitter on my phone with this UUID. And then I can test it manually without having to go drop this thing in water. A little bit of cleanup here. It doesn't show up well. But basically, I did a manual split of what the packet looks like and what I'm looking for. So I know the UUID is this section. It looks awful when you zoom in. So what I'm now returning is the Bluetooth that's before in the dictionary, but I'm also now pulling out a string packet from -26 to 6. That's because I want to start at the end. I know the middle and the beginning can shift. They can be longer or shorter, and I don't really care. I know it's always going to be offset from the end, though. So if you look at the packet that we have, I'm going to start from so that's 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So if I start from 6 and go to -26, I know that's the UUID. So that's what I need to parse. So again, just return the string version of that, right? So I have these bytes. Basically, I turn it into a string, concatenate them, and I'm good to go. Run the test, it passes. So now what I have is a library that's starting to pull this information in a smart way. What I need now is gravity and temperature, which are just the other 2 bytes. So there's the code change for that. TDD, of course. Right, so now I know I'm returning a dictionary with the MAC, the UUID, the major, which makes sense, right? I dropped it in water. It was about 66 degrees. And there was a little bit of sugar in there, so I know it's not exactly 1.0. It's never really going to be 1.0 if you drop it in water. There's other things that exist in water. So now what I have is I have the starting of a library that's actually pulling only tilt data from socket, which is really nice because now that I'm only emitting these dictionaries, not this biased view of what I want to do with it, I can take it to the next level. So what I started is this major project that's getting a little bit of traction now, but I have this concept of emitters. So basically, you can run it as a CLI or a Docker container. You just give it privileged and give it access to your network cards because that's where Bluetooth exists. And you can run it and submit it anywhere. So I have the idea of webhooks. There's a lot of them that you can post. You just need an authorization header and send it out. So this is a snapshot from Datadog. So I just built up a statsd metric and then submitted it to the Datadog host, and it goes into Datadog, and now I have a dashboard that shows the gravity. So that's very great. The idea that I'm getting at with this is that I like unified dashboards. If I'm brewing a beer, if I'm doing anything, I don't like to have to look at 2 different places, right, for a source of truth. And with that original project, that was never going to happen, right? That huge JSON file is not something that anybody can manage and add other data to. So come in, a new project. So there is a, I think they're a Norwegian company that makes these things called Play-Doh. There's an airlock, this is the one specifically, and I'm one of the first users to get it. And it was neat because what it does is you set a keg on it, and it kind of gives you an estimation of how much beer is in there by weight. So you zero it out, you put your keg on there, if what it is 0, you put it on there, and it can tell you you're about 100% full, you're about 50% full. It was really cool. And they have the idea of webhooks, which I wanted because I want that data in my unified dashboard. It turns out that's not happening for a while. It also has some other cool features that I want, like leak detection. So this is in that arcade machine, I don't want water in there. And it has a really cool app. This is the little gauge that tells you about how much is in there. It's not exactly accurate, but it's pretty accurate. So why would I do this? I want control, right? I don't want all these dashboards. I don't want apps on the phone. I'm not really a phone person. I don't want to have to check different places for different things. Their app sucks, I'm not gonna lie. It's all in like kilograms, and it loses settings all the time, and I just don't like it. The webhooks and this other stuff that I wanted isn't there yet, and I'm not paying for your cloud, let's face it. So they have this pricing model where you can get these webhooks for free eventually when they have it, but you can just pay for their cloud software and you have this dashboard. That's another dashboard. I don't want that. I want the data myself. So let's start. What's the first thing you should do when you get a really nice gadget? You should not take it apart. So I did. The reason I'm doing this, I don't know anything about this. I'm going in blind. This is a company that's kind of new. Nothing's open source. And I just want to see what I'm getting into. So take apart kind of gives me this idea. I see 3 what's called load sensors. And they give you a value based on how heavy it is. So that's kind of cool. And what I also see is this chipset called an ESP32. Those are the only 2 things in there. And this is an IoT chip. So it connects over 2.4 Wi-Fi, and that's about it. Now, it doesn't seem like much, but what that tells me is there's not a lot of processing going on in this keg. It's sending raw data, it has to be. There's no other chip, and that is not fast enough to do it. It has, I think, 1 mega flash. So even though I didn't get much out of it, it at least tells me what I'm not looking for. I'm not going to get a straight value of how much water or how heavy this thing is. I'm going to get some weird raw data. So now we're going to hack it. So is anybody in here familiar with what's called a Wi-Fi pineapple? All right, so I brought one we're actually using. So this, let's turn it on, is basically just an access point for internet. And it's really good. It's the reason that people say you shouldn't use open internet when you're at the airport and these other places. So if you connect, there's now an open SSID showing right now called Beer. And you can connect it if you want to. I don't recommend it because I'm going to take your data. Let's see. Wait for it to show up. Let's see. It takes a while for it to show devices. Just in case. So I've got it on a battery right now that can be plugged in. Hopefully it connects because I'm kind of hinging on this. I'll keep talking, I'll give it a second to show up. So what I'm going to do is I'm going to load this up and I'm going to connect the IoT device to it. It actually has internet. I have it plugged in right now, which is going to a Wi-Fi. So you can get on it, you can go to Beer, you can still browse it. So as far as the app, this device thinks it's fine, right? It's connected to your router, it's doing what it needs to do, and you can contact it. But I want to see what it's doing. So what I'm going to do is called PCAP inspection. What I'm going to, as it's connected to this device, I can dump every packet that is sent and received through. So I'm basically going to go, start it, turn that thing on, give it a few seconds to do what it needs to do, turn it off, and pull the data. And then we're going to go through DNS spoofing. So let's see.
There it is.
Is it showing up? There it is. Beer. Let's hack this thing. So now that I'm connected, I can get to the management portal. I got a password on it, don't try. It's not beer.
It's literally not beer. It's beer 2020.
All right, so I have a client connected, which is my laptop. All right, I know that because it says Marc's MacBook Pro. So I know nothing else is connected to it. I have a few modules I can use, but we're going to go dump the packets. So give go to TCP dump, get it started. So now, some mess of wires is connecting. So I'm gonna give it a few seconds, do what it needs to do, because I have no idea what it's gonna do. I'm gonna hit stop. So what that does is I get what's called a PCAP file. I've already got one. I don't wanna like hinge on this in case somebody actually did something I don't wanna show. And it doesn't tell you much anyway. So let's pull the PCAP file. This is literally every raw TCP that happened. And now, so my laptop is also connected, so I wanna filter those out. So what I'm gonna do is, it's source. So as it's a client, you can go and see what it was connected as. So I know it was connected as 225. That was its IP. So there's those, but it could also, so that's, if the source is its IP, that's the packets that it's in. I also want to see what it got. Or destination is 216, 42, 225. And again, that's just because it showed right here, right? I know what it connected as. These are the packets that it's sent and received. It doesn't really show up too great. I guess it actually does. So it kind of makes sense if you're looking at this is the list of packets in order that it's sent and received. The first thing it does is a DNS lookup. That's interesting to me. So if you look at the data, it's looking at plato.blink.cc. Now that's more information. That's good, right? I don't know what Blink is. Let's go find out. So if you Google Blink, you end up at this. It's gonna be a little slow because it's going up. If it doesn't load, it doesn't matter. Blink is an IoT company. Makes sense. So now that gives me a more idea. I have an ESP32 processor that's not doing much, and I have this off-the-shelf IoT framework. So I can, the reason that's good is I can do more homework now, right? Like I can look at the libraries that people use to interact with this thing and I get more information. Now what I'm not gonna do is click on this one. This actually shows the authorization packet that it's sending, and I only know that because I'm not gonna show it to you. I can't change it. So what I would do now is go to this one that's 91 bytes and I would get this, it looks like a UUID. That's also interesting. Because this long string of digits looks like an authorization, like a token. So what do we know? We know it's using something called IoT for Blink. It's looking for plato.blink.cc, I spelled Blink wrong there, over port 80. And I know that because when it's doing these talks, it says port 80. Yeah, here it is, port 80. So notice I have something on port 80. That's also interesting. That means it's not SSL. That's super helpful for me. Now, there is a Python library for Blink, and I'm going to use that because this token that it looks like, I want to see if that's actually the token. Easiest way for me to do that is they have this Python library that you can run interactively, right? And you can connect. And this line stands out to me the most is because I have something that looks like an authorization token. I have something that looks like a custom DNS entry, right? They have a version where you don't have to give it to it. That doesn't sound right to me. It sounds like they're actually specifying plato.blink.io or .cc over port 80. So this sounds right. So we're gonna do that. I'm gonna do it manually because I wanna see if that's actually a token, and I wanna see what it responds with, because it looks like it's waiting for an authorization response. If you look at the packets, it's doing that over and over and over again. That doesn't look like real data. It looks like it's trying to get a 200 OK of some sort. So I give it some random gibberish in that library. This is just the Python, interactive, and I get an invalid auth token. So I set it as environment variable because I know it's getting recorded. I don't want people looking at it. So I gave it that token that it looks like in that packet, and I don't get a failure. So that tells me now that I'm authenticating, and that's the token that it wants. Now, if I want it to talk to me, I need to do two things. I need it to talk to me, so I'm going to do something called DNS spoofing. I'm going to update DNS, and I'm going to tell it, when you want to look up plato.blink.cc, I want you to get this address. This is my laptop, and I'm going to listen on port 80. And then I need to figure out, if it's just going to tell me this token over and over and over again, that's not helpful. I need to find a way to tell it that it was cool. I don't actually care that it's cool, but I need to tell it, 200 OK or whatever it is. there's a few more things that I need to figure out. Blink uses this custom TCP wrapper that's only 5 bytes. So I can't just send, it's not a JSON, it's not HTTP, I can't just send 200 OK like as a JSON response to how you would think on a web page, I can't do that. So I need to figure out how. It turns out tests are awesome. So this place actually wrote tests, and that's cool for me, because they have a byte string that I need, just right there. Also, this is not me saying don't write tests. Please write tests. Here's a byte string. So this test tells me that it's going to receive something, it's going to try to authenticate, it's just going to say cool. That sounds like something I need to send it back. So that's where we're going to start. So we're going to go back to this. I wrote this very low level TCP. That is not the level. So I wrote this very low level TCP socket. I had to skip a lot to get it to fit on this page. But I'm going to listen on port 80. I'm going to receive it 1 byte at a time. And then what I'm going to do is they also have these things called commands. It's a 5 byte packet. So they have this list, like the code is 2, that means this to them. If the code is 29, it means this. That's also published. And I know in their code that commands 2 and 29 are different forms of authorization. So what I'm going to do is I'm just going to say every time you talk to me, I'm going to parse the command that you're giving me. And if it's 2 or 29, which sound like authentication to me, I'm just going to respond back with that byte that I got from the test. Just see what happens. Turns out that as soon as I send that, I get flooded with data. So what I've actually done is I've told it cool, and now it's finally talking to me. Let's prove it. I'm going to do it. So back at Wi-Fi Pineapple, I can actually, there's a module called DNS Spook. What I can do is give it a host file. And now anything that's connected to this Wi-Fi Pineapple will resolve plato.blink.cc to me, not 183 or whatever it was looking up. It's going to resolve it to 172.16.4.2.122, which if you look at clients is this laptop. And we can prove that part by doing a dig. So if I do dig, I get a local address. If I do ifconfig, same address. So I know it's going to talk to me. So I have to use sudo because it's port 80, which is a privileged port. So now it's just sitting here. It's waiting for something to come through. We're going to turn this thing on and see what happens. Oh, I already had it on, so it's waiting. So it was sitting there spinning over and over and over again, waiting to get a 200 OK. And I finally got one because my laptop started responding to it with that. And now I get data. Now what's cool, I told you this is a skill. Let's see if those values are actually what I think it is. So it's just sitting there, and if I push on it, I should get an increase of values, assuming it's not dead. So I unplugged it, plugged it in, we're going to send that auth code. Live shows never work.
Yep.
I mean, it did work, but for some reason now it's not wanting to show me the increase. But I get some cool information, right? So it sent me code 29, which is that one that I did in the lookup. I sent it an auth success, which is what I got from that test. And then out of nowhere, I just started getting all this other data, which is interesting. It gives me the firmware of what it's running. I told you it's an ESP32, so that lines up the way I'm thinking it does. A timestamp, some other information that I may be interested in later. But it's also giving me what looks like load values, right? I'm getting 3 digits, which makes sense because I have 3 load sensors, and they're raw data, so I can turn it into that. And there's a little bit more that I will parse later too. There's this that looks like kilograms. Maybe it's trying to do some buffering there, I'm not sure. But the point is, I just intercepted all its data. As far as it's concerned, it's talking to me, which is kind of cool. If this was a more intelligent device, it would actually be waiting for ACKs, right? It wouldn't just send data to dev null, right? It would just wait for a response and make sure that it's receiving. But because of the packet that they're using, that 5 byte packet, it doesn't look like it actually cares. It's just pulsing over and over and over again. So the code doesn't actually have to be very complicated. In fact, that was basically the code that I showed you in its full entirety was this. So what's next? So I didn't get time to kind of go as far as I did with the tilt hydrometer in terms of that, but what I could do now is I can create something that's literally just listening for that and doing this interpolation myself, right? The load values might mean this. I can zero it out. I can put a known 10-pound value on it, and I know that 10 pounds means this. I can do that on my side, but what's cool is it goes back to the other part. I can send this to my own dashboard. So now I can have this Datadog dashboard or StatsD with all these other hooks. There's brewstat.us, there's all the other ones, and I can control all those in one dashboard and not have to use the Play-Doh app or the Tilt app with a Raspberry Pi and all this other stuff. If I want to make it complicated, I can do it myself. So we're going to do a post-mortem. Because it sounds kind of scary, it's actually not. Was I hacking? Not really, right? I pretended to be somebody I'm not, but I wasn't actually hacking. I didn't break anything. I didn't lie, right? But I did reverse engineer. I took their packets and I kind of figured out what they were trying to do, and I'm pretending to be that person. So how would you prevent this? So if you look at the library, they're using port 80, right? That's not SSL. Now, there's two ways that you can do SSL. In this case, you can do what's called strict SSL or not. I've talked to plenty of people, and they say that, we turned on SSL and it's fine. Well, if it's not strict, it doesn't stop it. You know why? Back at the Wi-Fi Pineapple, there's this thing called SSL split. And what that actually does is on the TCP dump, it's actually going to present everything that you do with a self-signed certificate. Now, Chrome, Firefox, they make these things very obvious, right? You go to a site with a self-signed cert, you go to Google, and it says, hey, this is signed by localhost. It's not going to work, right? They do strict SSL. So what they're actually doing is saying, like, I want to take the certificate that they're presenting you, and I want to verify everything about it. Is it TLS? Does it have SNI? Does the name that you're presenting me line up with the root CA? Does it go upwards? Do I trust it? All these other things. Just enabling SSL does not do all of that. So if they just turned on SSL, I would just do the same thing, turn on SSL split, present it with a self-signed certificate, and I guarantee it would still give you the data. So to prevent that, this is where I always say, always enable SSL where you can, and always turn on strict. TLS 1.3, all these other ones with like SNI lookups, turn them on even though it doesn't seem important. It's not a big deal in general, especially like the cloud, right? Because it's really hard to get between your devices and the receiving endpoints. But state actors can do this. There's a lot of other ways that people can get in the middle. And if you're doing full encryption end to end and you're actually verifying these things, you can prevent a lot of that. So that would have prevented me, hands down. And what is reasonable disclosure? So reasonable disclosure is something that I tell everybody. I did this, it's not really hacking, but I'm still going to email them at the end of this. I didn't want them to shut it off before I did the talk. I'm going to email them. It's not actually a vulnerability, right? But I do want to let them know, like, hey, I found this out. You should enable SSL, and kind of give them the same spiel. But if you ever find anything like this, I always say, please do a reasonable disclosure. Look up the company, see if they exist, and just email. Usually it's security at company name. Just let them know. Because odds are, a new company just doesn't find this important. Maybe it's not important. Maybe they don't care, and I'm just going to keep going on. But being in the security industry, that's always my forte. Is just tell us. Because maybe we've wanted that for a long time and we didn't have the justification to do it. So there might be somebody that's been saying this all along and they're like, oh, it's not a problem, and then they get one email and then that's kind of what changes it, everybody wins. So now I leave it open for questions. From anybody that's not a lawyer.
Since that's just a ESP32, is there headers that are available or JTAG that you can hook into?
Technically, no. If it wasn't so expensive, that kind of crossed my mind. The problem is, I don't want to have to figure out what they did to read those values. And they've probably gone through a lot more testing than I have. I mean, they're just 3 looks. It's just, I could do it myself, right? If I was going to do that, I would just build one myself at this point. I don't really care. It's sending me the data, so I don't really have to. It would be nice because then I can push my own firmware updates, especially because ESP32 supports over-the-air updates. I could write my own, but at some point I got to decide, like, is that worth all the effort? The answer might be yes, but I mean, it's soldered to a chip. I could find a way to get some pins on there and read them right to it like I would any ESP. But there's definitely no JTAG on there. Any others?
Part of that was kind of like, wouldn't it just almost be easier to build it? And I know this is your forte, basically, and doing the security analysis of it. So that's your interest, and that's why you approach it from that angle. But building something like this, not, like you said, not complicated. It takes some trial and error. 3D presentation. But so to your, like you want to contact them and tell them that this is a vulnerability and you're going to suggest that they enable SSL. So if all companies did that, that just promotes logging. That just promotes that, again, they're going to want you to use their cloud service, that as soon as they're going to go belly up, it's a startup, most likely going to go belly up in a few years. And then you have a dead device. Why not just have, I'd rather see companies promote protocols that people can take over and keep alive.
I agree, but it's hard to make a company on that, right? This is a company that wants to make these dead simple, normal person, plug it in and get it on your phone, and it turns out that there's a small subset of us that aren't like that, and I'm one of those, right? I want to know how it works. But most people, to be honest, don't care, right? They don't care that it's not talking SSL. They don't care that they're paying a little bit more for somebody else to make it for them, because you literally plug it in, put it on your phone, and you're good to go. The amount of effort involved in that would be pretty gross to the normal consumer. Something like the Tilty or like the ones that are super specialized, I can see that being a justification. But like a scale is just so, it's not really geared towards like the super geeky ones, right? It's a scale. Almost anybody with a keg at that point of any background is interested.
The size is for a corny keg, so they're targeting the homebrew audience.
Yeah.
It's already a pretty geeky audience.
Yeah, but not necessarily technology, like
Okay,
geeky
fair,
technology.
yes.
My answer would be I would love everybody to support some sort of open source in that, right? But I don't see that winning over very well if I email them and ask for their code. So, and I want to support them, right? They make a cool product. This thing is awesome. It's got gaskets in it, all this stuff. If I were to make this, it would take me a year, 2 years, and it would come out half as good.
Yeah.
So I want to work with companies as much as possible to make sure that they are giving me what I wanted, and that's kind of where sometimes I have to go in the middle like this. If I wanted webhooks, I'm going to have to roll it myself, even if that's different.
But if they secure it, you no longer have access to that until they provide you the full webhooks.
True, but the security side of me would be very excited that they actually secured it.
Sure. Okay.
So I don't know. If there's no good answer. I would love for everybody to embrace open source. And the answer is it's really hard to build a company on that. I would love it. Any others?
Just something to add. I'm actually an embedded systems engineer, and embedding the TLS stack takes a lot of resources.
Yeah.
I know the ESP32 it's got enough to do it, but some of these smaller micros that do have Wi-Fi, it's
And that's the other, yeah, right. But as soon as you import all this code, right, it gets fluffy, especially things like OpenSSL and all these other ones. They are not light libraries. So the forked versions of those also have their own life cycles, basically, right? To support those, we would have to see an increase in size alone on the processors. Like the ESP01 would never support it. I think that's got like a 500K flash size. What's up?
Any other cool nerdy homebrew stuff you want to talk about?
There hasn't been a whole lot going on. There is a project that I'm backing right now that I'm working with. It's a conical fermenter, but it actually has glycol that goes around it. So you wrap it in a sleeve, and you can actually. So when you're fermenting, you want it at a specific temperature. If you're doing a lager, you want it like 32 degrees, like not 32, but right at 32 degrees, so it's very cold. But if you're brewing normally, you want it in the 70s range, and in Tennessee heat, that can easily be 80, 85, and it can add off flavors, among other things. So the one that I'm backing right now that I'm working to get set up is it's basically a glycol chill fermenter that monitors just like an AC unit. So when the inside temperature is not a certain amount, it'll pump cold glycol through it and keep it within range.
You gotta hack that with
It's not smart. What I'll do is I'll add a chip to it. Anything else? That's it.